Hello everyone, this is Eddie the Magic Monk. Welcome to another maths tutorial. Today we're going to show you guys how to solve matrix equations involving the distributive law. So what is the distributive law? Well, let's firstly write that out. If you have let's say we have three matrices. Let A, B, and C be matrices. Okay, and let's write out a matrix equation like this: AB plus AC. Okay, now if you guys remember factorizing with normal numbers, you can also do that with matrices. So this then becomes A bracket B plus C. Okay, or you could also go the other way, A times B, so you expand it, so A bracket B plus C, so you expand it like this, equals AB plus AC. Now this will work with matrices as well as normal numbers, which is great. Okay, the other way is you could go, let's say we rewrote this equation so that A is at the back, so CA. Now you can see that both of these terms have A in it, but they're at the back of each term. Okay, so when you factorize it, what happens is you have to, and I repeat, you have to put the A at the back of the brackets. Okay, so if you put the A at the front, this will work with numbers but not with matrices, because remember, with matrices, AB does not equal BA, right? Matrices in general is not commutative, so that's why you have to put the A at the back. And then similarly, if you put B plus C bracket A, right, you would go B times A is BA, C times A is CA, and so on. Okay, so this is the distributive law, and let's now apply this to rearrange a matrix equation. So now we're going to rearrange an equation to make matrix X the subject. I'm going to make up four matrix variables, A, B, C, and X. They're all matrices, and if I have AX plus 2BX equals C, try to rearrange it to make X the subject and come back when you're done. Okay, so the answer is we're going to factorize it using the distributive law like we did over here. So this equation actually matches more closely to the second one. Okay, because we have A, which is the unknown variable, at the back. So what we're going to do is we're going to put A plus 2B at the front, multiplied by X is equal to C, right? Because A times X is AX, 2B times X is 2BX, right? So now all you have to do is do the inverse of A plus 2B, and we're going to multiply by that at the front of both sides. Hopefully you would already understand what the inverse does. So you can see that I've multiplied by this term on both sides. Okay, so now this then will cross out, which will turn into the identity matrix, right? Because any matrix multiplied by its own inverse will become the identity. So the answer is just x equals, and we can just copy this down again. So we have achieved our goal, which was to rearrange this equation to make x the subject. Right, we've achieved our goal. Okay, now once we have done that, this should make this question a lot easier. So the question is going to be, solve the equation wait, I need to see this. Okay, so we have -1, oops, why is it doing this? -1, 3, 1, -2 times x plus 2 times another matrix, -1, 3, 1, 2 times x equals let's make C 12, 12, 10, -1. Okay, so there's my problem. See if you can solve it, find out what x equals, and come back when you're done. Okay, so what are we going to do? Well, we have to use the distributive law, just like we did over here. We factorized it by putting x and the 2b out at the front. So I'm going to do the same thing here. So I'm going to put -1, 3, 1, -2 plus 2, -1, 3, 1, 2 at the front times x is equal to, and I just copy down the right hand side again. Now, why did I do this? Because if I have this term multiplied by x, that'll give me this term. And if I have this term multiplied by x, that'll give me this term. So it all works. Okay, so let's try to do this calculation, because you can see that inside this bracket there are no variables. So you can just type it all into the calculator. Okay, so we'll do this part first. So it's -1, 3, 1, -2 plus, and this part will be -2, 6, 2, 4, right? Because this is a constant at the front, so you just multiply it into all the terms. Okay, and then when you're adding matrices, you just add each number to each of the corresponding numbers. So -1 plus -2, write the answer in the first spot. 3 plus 6, write the answer in the second spot, and so on. So 1 plus 2, -2 plus 4. So you put all that in, and then you will get -1 plus -2 is -3. 3 plus 6 is 9. 1 plus 2 is 3. -2 plus 4 is 2. Okay, so that's the answer. So I'm gonna put that. Let me just delete that. Delete all this stuff. Okay, and I'm gonna. Oops, it's not going away. And I'm going to put this over here. Right, so that this here represents all of this. Okay, so this times x so I don't need this anymore. This times x, is equal to 12, 12, 10, negative 1. And then let's get the inverse of the matrix at the front and multiply it on both sides. So I'm going to go negative 3, 9, 3, 2. The inverse of that, multiply by, let's go back to green, negative 3, 9, 3, 2, x equals, and I'm going to multiply this inverse again on the right hand side at the front and multiply by 12, 12, 10, negative 1 again. Okay, so I have this big equation. In this part on the left, I know that it's going to equal the identity matrix, so I can just cross it out. So then the answer is just x equals, and let's just type all that into the calculator or work it out manually. So the inverse of this matrix is, if you're working it out manually, just keep it as a fraction, but because I typed it all into the calculator, and what the calculator gave me as the inverse is negative 0.06, 0.27, 0.09, and 0.09. So that's the inverse of this matrix. Times it by 12, 12, 10, negative 1. Okay, and then you would multiply this together and you will get 2, negative 1, 2, 1. Okay, so that we have just solved the equation. If you want, you can check it. So let's copy down our original equation. Okay, let's copy this, put it down here. And if you want to substitute in x, which is what we found over here, if you want to substitute in x, if you want to substitute this into these two positions and see if you get this answer, and then you would know that we are correct. Okay, thanks for watching guys, see you next time.